In this video, we'll talk about oncogenic mutations in PI3Ks, and specifically, we're talking about class 1A alpha. Okay, so we know that there's a regulatory subunit and there's a catalytic subunit. Okay, the regulatory subunit is the P85, and this would be the P10 alpha. Alpha here as well. Now, usually, how is it? Well, the regulatory subunit is it's called so because it regulates the catalytic subunit, right? So, how does it do that in general? The regulatory subunit, the P85 alpha, inhibits the P10 when catalysis is not required, so that P10 will not go about catalyzing any substrate. Okay. So, so it's inhibiting it, but we do need the catalytic subunits when we need to phosphorylate things, right? So how does it relieve P10 of this inhibition? So when P85 has SH2 domains, and when these SH2 domains bind to IRS1 or receptor tyrosine kinases, then that relieves P10 of this inhibition caused by P85, and it causes the P85 P10 complex to go to the substrate and phosphorylate it. So it causes substrate phosphorylation. Alright, so this is how it works. Now, what causes oncogenesis? Well, there's two ways you can have oncogenesis in these protein kinases. Number one is if you have a mutation in the P85 subunit. If you have a mutation in the P85 subunit, that will cause loss of inhibition. So basically, both the cancers are caused by loss of inhibition. Okay, so if you have a mutation, P85 mutation, then obviously it will not be able to inhibit P10 anymore, and P10 alpha will go on catalyzing reactions, and we know that these protein kinases are responsible for converting 4,5P2 into PI3,4,5P3, and this goes and activates PKB1, which activates PKD. Just 1 second. I keep forgetting this name, and I should not. Just 1 quick second. I'll find it quickly. Here. So PDK1, sorry, I just got the names mixed up. So PDK1, and then PDK1 goes about activating PKB, which is involved in cell protein synthesis, glycogen synthesis, glucose uptake, and so on and so forth. So obviously, if we do not have any regulation over this, then we'll keep on having these things and ultimately cause ourselves cancer. So that was a little side thingy, but this is how it causes cancer. Now, so you can have a mutation in the P85 subunit, or you can have a mutation in the interface between the SH2 domain of the P85 and your regulatory subunit. So even if you have that disruption of the interface between, and specifically between the NSH2 domain, the N-terminus SH2 domain, and the P10 interface, disruption will also cause loss of inhibition, and you will get a malignant phenotype or cancer. Will make it oncogenic. Okay. So that is about what causes oncogenic mutations in PI3Ks. Now we'll talk about some locations of phosphoinositides. Some important ones, locations of phosphoinositides. And I have such a funny way of remembering this. Well, I just write all these in sequence. So first you have PI3P, then you have PI4P, then you have PI3,4P2, and then you have oh my god, did I mess this up? 3,5P2, and then you have 4,5P. PI3,5P2, and then PI4,5P2. These are the important ones, and you need to know the locations. And the way I remember this is I have a mnemonic made for it. So I have excellent girl lipstick pudding. This is totally ridiculous, but it totally helps me remember this. So this PI3P would be early endosomes, G would be Golgi complex, L would be late endosome, and P would be plasma membrane. Totally helps me remember it. It's coming to an end. See you in the next video.